Hello students, in this video I will be applying the following logarithm identities in several different exercise questions. So let's take a look. So what I'm asked to do is to evaluate log base 7 of 343. So how am I going to do this? Well, I don't know about you, but when I look at this, it's hard to tell what this is really asking for unless I attempt to maybe do a little bit of conversion, right? So let's say if I say this thing is equal to x, then what I'm asked to do is to figure out 7 to what power is equal to 343. That is the conversion, right? And again, I am applying this guy, the first bullet point there. Okay? All right, so 7 to the x is equal to 343. What is that? Well, that seems to be 7. Well, I know that 7 squared is equal to 49, right? 7 to the third has to be 343, right? And if you want to check to confirm that, let's do a quick check here. 7 to the third. As a matter of fact, it is 343. All right, so therefore, x must equal to 3. So again, the evaluation here is, or the most convenient logical thing to do is to rewrite this as an exponential equation. Let's take a look at the next one here. Log base 2 of 32. What will that evaluate to? Well, this is really saying 2 to, let's say if I call that x, right? That question mark is x. This is really 2 to the x is equal to 32. So this seems super familiar, doesn't it? Right? 32 is the same thing as 2 times 16. And I know that 16 is 2 to the 4th. 32 is 2 to the 5th. So therefore, x must equal to 5. Let's do the next one here. So again, this is equal to something, and I'm calling that x. So this is saying 6 to the x is equal to negative 216. This is impossible because there's no number that I can substitute in for x that will give me a negative answer as a result. So because of this, there's no solution to this. Right? Think about that. Take a positive number, raise it by a positive exponent or a negative exponent. You will not end up with a negative answer here. If you're wondering, like, well, what about imaginary numbers? We're not going to take that into consideration here. We're only going to be taking into consideration only real numbers, okay, for this exercise. Let's take a look at the next one. So again, I'm trying to solve for what this is equal to. Let's call that x. This is the same thing as 64 to the x is equal to 16. In order for me to solve this by hand, I need to convert this so that it has the same base, right? So 64 is really 4 to the third, right? And 16 is 4 squared. Well, looking at this, then I can see that 3x is equal to 2. What would x have to equal to? X must equal to 2/3. Right? Let's do a quick check. 64 to the 2/3. It indeed is 16. All right. 2 to the negative 8, right? It's the same thing as 2 to the x is equal to negative 8. Again, based on what I said earlier, there's no such thing, right? Any exponential function where we take a positive number and raise it by some number, it will never ever be negative. And because of this, there's no solution here once again. I hope you're beginning to recognize this now. Anytime what we're trying to take the logarithm of, right, if that argument is negative, there's no solution. It's outside of the domain, right? If you recall, log base a of x right? The domain here is x is greater than 0, and it has to be greater than 0. Actually, I'll leave that. All right. Log base 2 of 8. This is the same thing as 2 to the what power is equal to 8? Well, this must be 3 then. Log base 4 of 16. So this is 4 to the what power is equal to 16? Well, that's 2. 6 to the what power is 216? Well, 6 squared is 36. 6 to the third is 216. So this must equal to 3. 2 to the what power is equal to 1/8? Well, 1/8 is the same thing as 8 to the negative 1. And it's the same thing as 2 to the third to the negative 1, which is 2 to the negative 3. Therefore, x must equal to negative 3. This is negative 3. Let's take a look at another one. All right, so now it says to rewrite in exponential form. It doesn't say to solve, so that's what I'm going to do. This is the same thing as 5 to the x is equal to 73. This is the same thing as 5 to the third is equal to 125. And is that the case? That indeed is the case. 225 to the 1/2 is equal to 15. Seven to the third is equal to 343. All right, now we got to rewrite into logarithmic form. This is already in logarithmic form, so I think I may have placed the instruction in the wrong place. I think that's what it should be, so my apologies. So we're still rewriting into exponential form here. So this is x to the y is equal to 181. All right, next, question 32. We got to rewrite this into logarithmic form. So this is the same thing as log base y of 140 is equal to x. Next one, log base of 13 of 1/169th is equal to negative 2. Log base 19 of 361 is equal to 2. Log of y, log of base y of 193 is equal to x. Log of base 3 of 27 is 3.